Okay, so any questions? Okay, if there are no questions, let's move on to the next uh, way. So, so sometimes, I mean, when you are collecting data, there can be um, many types of data. So, you might require to do some kind of analysis, but not all the data will be relevant to for that analysis, right? So here, if you go to the attribute table, you can see even though it says that this is a set of criminal data, a lot of data which is not actually pretty much required for uh, criminal analysis can be seen here, right? So, for example, the the code of the area that has happened, that this crime has happened, maybe the location, the police, right? So let's say if somebody asks you to do some analysis regarding the crime type, which kind of criminal activities or what is the crime types which has more often happened. So you do not need the latitude, longitude information, the police information. Even though you might not need the area where the crime has happened. You only need to focus on the crime type, right? So this violence and sexual offences have happened more. Uh, burglary, burglary might have happened less, antisocial behavior more. So like that, you might only need to focus on crime type. So in that kind of situation, we can give a weight for that particular um, attribute, right? So sometimes you may want to give different importance for each point. So the point which is the crime type, it takes more importance than the other data. So if somebody asks you to do analysis regarding the crime type only, then the crime type column or the crime type attribute gives more importance uh, than the other attributes, right? So for example, a more violent crime should have more influence on the output heat map than a robbery. So in this crime type also, there are different crime types. So stealing somebody uh, money or something, that is also a crime. Killing a person is also a crime. Uh, Sexual violence is also a crime. But I mean, you feel when somebody steal maybe uh, a, a, let's say somebody steal a coconut from a person's land, then do that person go to court and uh, proceed with all the lengthy stuff? No, normally they just forget about it. They just make up their mind. But if somebody comes and kill a person, a family member, then what happens? Then that the people on their in their family, they do not just forget that incident, right? They go to court, they appeal for justice and do many other things. So you can see the severity of the crime differs according to the type. So normally, so when we are creating heat maps, we might need sometimes we might need to uh, distinguish, or we might need to visualize a more violent crime with more influence or with more heat, right? So if a particular area has records where people kill each other, then that area is very dangerous, right? Unlike the other criminal activities. So let's say violence and sexual offenses, that is also a very critical crime type, right? Burglary is less critical depending related to this violence and sexual offenses, criminal damage and arson, right? Drugs. So bicycle theft, this crime type is less critical, right? And shoplifting means going to a shop and stealing from that shop. Vehicle crime. So you can see there are many crime types, right? Antisocial behavior, right? Behaving in an antisocial way, right? Uh, Theft from person, right? So you can see different crime types have different weights. Uh, So similarly, sometimes a point may represent multiple observations at a single location, which needs to be accounted for in the analysis. So in when we take one point, it might represent different or many observations in a single location. So theft might happen there, other criminal activity might have happened there, sexual violences might have happened there. So in the single location. So that single location or that single point need to be highlighted then, because that is a place where it is very dangerous for the other people to live. Right? So in order to do this, in order to increase the influence of a particular point, we need or we have an option called numeric weight field, right? So we are adding a new field or a new column to this attribute table, which specifies a value for each point. So use the crime type to categorize the different types of crimes and assign a higher weight to more violent crimes. So we will assign a higher weight to more violent crimes. Right? So how are we going to do with this is we are going to use the field calculator. So there's an option called field calculator. So we are adding a virtual field, right? A virtual field is saved in the QGIS project and doesn't modify the source data. So we are adding a new column and new data will be there, but that will not affect the original data which was already there in the attribute table. So that is a virtual field, right? It is also dynamically computed and can be used anywhere in QGIS, just like any other attribute value. So when you add this new attribute into the attribute table, you can use it in any QGIS application, right? It is dynamic. So how we are going to do is we are going to open the field calculator and you have to write a case statement. I think you already know how to write a case statement, a switch case. In many programming languages, we have this case statement. So what we are doing here is we are comparing the crime type. We are comparing the crime type. If the crime type is violence something, then we are giving a higher weight. If the crime type is criminal something, then we are giving a much lesser weight. If it is another crime type, then 1. So I'll show you how to do it. So what you're doing here is you have to go to the field calculator here. When you click it, you will see this kind of a window, right? So you have to give an output field name. So this is the name of the new column. So I'm going to just type weight crime type weight, crime type weight. So the output field will have a whole number. I'm not going to add decimal numbers or text or anything. So you can add any data type here. Then output field length will be 10. Yeah, 10 will be enough because I'm going to give numbers probably lesser than 10. So what I'm going to write here is I'm going to write a condition, right? So you can select the conditionals from here. Double click on case, case when. So here you have to write the condition, then the result, right? So the condition means um, in the condition I'm going to write. I'm going to check the crime type. So here the crime type. If the crime type, so I can just equal to a value. So if I select the crime type and click all unique, you can see here all the crime types are here. So I'll just write violence and sexual offenses. It is the most critical crime type here. Then the result will be I'll just give as 10, right? Then 10. Okay, so when crime type. So here in your handout, actually, they have what do you say? They haven't given the whole unique value, unique. Yeah, the violence. They have only given violence, and there's a percentage mark. So if you can see here, it is like it is. They are. I think you know the meaning of this word like, right? So if you have done database management systems, or if you have done any other programming languages, you might come up with this word like violence and a percentage mark. So any word with violence in front will get 10. Will get the weight 10, right? Right. So like that. Uh, I'm not going to give like. I just yeah. So here I'm going to write uh when crime type equals, so let's say what is the criminal damage, let's say criminal damage and arson, uh, then I'm going to give 9, or let's say 8, right? Then when crime type equals, let's say drugs, drugs is also a serious crime, then when crime type equals, let's say a robbery, and I'll give 4. and when crime type equals, let's say, vehicle crime, just deciding and writing this. Yeah, like that. And let's write another one. When crime type equals burglary, then what? Then 1. And I'm going to finish my statement. So all the others, else, everything else is 0. Okay, so I'm going to click on OK. And if I move on to here, you can see the crime type weight. A new column has been created related to the crime type, right? The crime type weight here can be seen. So depending on the crime type, so violence and sexual offenses, it takes the highest value, and the other, this antisocial behavior, bicycle theft, everything, I have given to the else part, so it takes 0. Vehicle crimes have the lesser weight, and burglary, it has weight lesser than the vehicle crime. So you can see here, yeah, drugs have the weight as 6. So the values have been updated like that. Okay. So like that, you can add weights to the specific column that you need. Then we have to add the weighted points into the into our heat map. So you can, if you go to this, so I'm going to close this. If you go to the layer styling again, you can see there's an option called weight points. So I'm going to select weight points, and I'm going to click on crime type weight. So you have to select the new column that you have included. Then if I click on apply, you can see there's a slight difference. There might not be a very what do you say, very clear difference, but okay, I'll show you again. So if I just remove this weight points, so here I'm not checking weights, and I click on apply, and you can see, if you look here, there is less, I mean, heat is not actually there, right? And after this red circle, there is no other colors, just these light colors are available, right? But if I apply this crime type weight, and if I apply it, you can see a more heat is applied here, and more heat is applied around this red color circle. So if I click OK, and here also previously heat was not there, but now somewhat of heat has been applied, right? So so if we zoom in also, you can see these red colors, I mean the heats have been updated, right? So you can zoom in and see. So here in the commercial way, so there is a road called commercial way. So certain mostly sexual violences might have happened here because we gave the um, largest heat, which was sorry, we gave the largest weight, which was 10, to sexual violences, violence and sexual something, that kind of crime. So that kind of crime might have happened here because the color is red, which means uh, the larger weight is being shown here. So like that, we can zoom into certain places and see, right? So this is the broad way. Okay, let's see if we can okay, so like that you can pan here and there, so you can see here also a very critical crime, or a criminal activity, which is it is wind survey, right? So if I right click and go to the attribute table, so you can always click on this column header, and it will be sorted, right? Uh, so here there's a location. Okay, so if I just randomly select these points and check if I can see in my heat map. Yeah, I might not be able to select the points clearly because they have been converted into the heat map. So like that, you can add weights to certain data and change the heat map uh, according to the way that you need to explain it, right? Okay. So there is something called heat map kernel density estimation. So if you need the heat map visualization to be saved as a permanent raster layer, or you want to customize the heat map with advanced options such as different kernels or dynamic radius, you can use the heat map kernel density estimation from the processing toolbox. So QGIS gives a lot of opportunities to do a lot of things. So you can try this. There's you can go to the processing toolbox, and there you will have um, an option called under the vector general, you have the option called reproject layer. So before creating the heat map, reproject the source data to a projected coordinate referencing system. You have to uh, project the source data into a new coordinate referencing system. So since this set of data is related to the British, or to London, the best coordinate referencing system will be this one, 27700. Right, so this is the British National Grid Coordinate Referencing System. This projected CRS is good choice for the data in the UK. So since you are using the data in the UK, it is best to project this in this coordinate referencing system, right? So then let's yeah, I'll show you how to reproject this. So I'm going to close this, and under the processing toolbox there is, so this is the processing toolbox. So under the vector general you have reproject layer. So when you double click this, you can here you can select yeah, you can select the CRS as 277. Yeah, so this is the British National Grid. So you can see here it covers the whole grid. So our data points are also there. So you can click OK and you can run this. Yeah, so it will be run. Yeah. So it is successful, and you can close this and you can see. So this is the reprojected layer, right? So if I untick this, you can see this is the reprojected layer. So then afterwards you can select, you can do the kernel density. So here under the interpolation tab, you will have heat map kernel density estimation option. So you can go to the interpolation tab and heat map kernel density estimation. So here make sure you have selected the reprojected layer here, and then this is the kernel density estimation. So in this window you have you have been provided with several settings. So here the radius, so these settings are actually the best ones which I have selected with related to this data set, right? So here the radius I have given as 5,000 meters. So you can, yeah, you can write as 5,000, right? And the pixel size 50 and 50. So pixel size will be, and this one also it will automatically be converted to 50. So the rows and columns will be changed when you change this pixel size. So output raster size, which means the output of the map. Here we are talking the output of the map, the final map, right? So under the advanced parameters, we are going to select the weight, right? Weight from field, crime type weight, right? So that is all. So we can run the run this algorithm, right? So it takes a little bit of time to process this algorithm. Okay, so yeah, almost there. Okay. So you can see here something, maybe something that you have not expected. So it is pretty much ugly. So you can see uh, it is a heat map, but it is a little bit that we cannot clearly distinguish, right? The where the high density are or where the low density data are. So the default visualization is ugly since it uses the single band grid renderer. So it uses one type of uh, renderer. So only black and white is being used. So we can change the render to single band pseudo color and select the red color ramp. So you can change to any other styling which you can, which you prefer, right? So for that we have to go to styling. Okay. So under symbology, the single band gray is being selected. So it is, you can select this one, single band pseudo color, and you can select a color ramp. So maybe select this color ramp. So here you can see the values. So there are 1, 2, 3, 4, 5 values. So these values are depends on the number of weights that we have given. Remember, we gave the weight 10, 8, 6, 4, 2, and 1, right? And 0. So 0 the color with 0, it has this uh, color, and the other what do you say, the other range, it has these color. So like that, depending on the weights that we have given, these color ramps have been, I mean, according to the number of colors which are there in this spectral color ramp, the weights have been distributed, right? So we can always change. So 1, 2, 3, 4, 5 colors are there. So you can always add a new color as well. So that depends on you. So you can right click here and you can select a new color. Right. So I'm going to select, yeah, this kind of color. So it is somewhat orange color, right? And yeah. So here I have 6 colors. Then if I select OK, so 6 colors will be there in my color ramp, right? Um, so you have to change the color ramp suitably. So you can select the interpolation as discrete. So when discrete, you can see here all the color ramps, all the colors. So this is the new color that I have added. So all the colors which are there in the color ramp will be uh, drawn like this. So this will be, the values will be dependent on the weight, the crime type weight, right? Uh, so there are some other settings as well. You can check with them. Right? So if I apply it, you can see. So yeah, it is better to let's see. It's better to invert it. So you can see here, it is more distinguishable, right? For it, I mean, you feel that there is a heat map here, right? Rather than in the previous types, previous ways. So if you can decrease the opacity. Yeah. Yeah. So here I have yeah, changed the opacity as darken. So these points are actually have come from this reprojected layer. You can simply close that layer. So yeah, you can, I'm just applying it like this. So if I untick this, so here you can see on top of the base map, the heat map has been created, right? The heat map has been created using the kernel density estimation. So it is an algorithm actually. Using this kernel density estimation algorithm, we can create a perfect heat map, a more clearly visible heat map. So here, unlike in the previous heat map, so if I untick this and tick this heat map, yeah, so this was the previous one, right? So this was the previous heat map. So you decide which heat map is more clear, this one or this one. So this heat map, I think it is more clear, right? So uh, you can explain something, you can talk about the data, or you can uh, tell the stories using this heat map, right? So that is how you should create a perfect heat map for your data set, right? Any questions? So you just follow your handout. Nothing out from there is needed to be applied. Just follow your handout, and you will be successful when creating the heat map. The only thing is you have to change the values of the settings to see which is the best value to clearly visualize the heat map. And you can also change the styling, the color ramp and all to clearly visualize the heat heat map, right? So I'm going to give you a little bit of time to, I think we did up to this point, right? We did up to this point. So you can start from applying weights to your attribute table. And when you are applying weights, you can use any type that, I mean, any way that you want to apply weights. So for example, here, I didn't use uh, the same weight application which is mentioned here, right? So you can use your according to your desire, right? So apply the weights and go on with your handout and try to finally build the kernel density heat map, right? So I'll give you a little bit of time, like around 10 to 20 minutes to be familiar with it. And when you are working, remember, if you come up with any questions, please ask right now, because otherwise you will forget the issues, and then when you are going to answer your assignment, you will be stuck. right? So it is better if you clear yourself at the moment, right? So people who are confident with creating this heat map, I have also sent you another exercise. I think I have sent these files separately for you. So you can create an animated time series data, right? You can create an animation using heat map. So here also step by step everything is been explained. If you feel like you are confident with creating heat maps, you can try to build this animation, right? So if you can build this animation and show us, then it will be very, I mean, yeah, very good if you can do it. But please, if you are not confident 100%, please go through this activity right now. I'll give you some time and you go through it and let me know whether you have any issues or anything else to know about it, right? Okay, so were you able to complete the handout? Initia, Chamesh, Himasha,
Yes, ma'am.
were you able? Yeah?
Yes, ma'am.
Okay, no issues.
No issue, ma'am.
How about the others? Okay. Okay. Okay, so that will be all about QGIS. So you will, by now, you will be able to answer all the questions which is related to QGIS. I think apart from three questions from all the other questions you are able to answer. You are able to make maps, heat maps, calculate line lengths and everything, digitize maps. Right, you can do all of them by now. Right. So yeah, I'm not going to save this. Okay, so next we will, as I mentioned, we will move on to talking about okay, so first of before that, I have given you this handout, animating time series data. This is actually um, animation is not required in your assignment. You do not need to animate anything, but this is very interesting. That's why I have given you. So these two shape files also I have given you. The folder which includes these shape files I have sent you, so you can use them in your map, and you can animate. So the thing is, you are creating heat map as in the same manner. So here they are using layer styling to create the heat map. So you can use any color ramp that you like, and yeah. So the thing is, they have loaded the map. They have given you a map, so you have to load the map, and you have to create the heat map. I think yeah. So everything is given to you. You have to just go through this. So here, this is the option to add the time feature uh, to your map, right? So I think this is something related to the ocean waves. So you just go through this. You have to do a little bit of querying and programming stuff as well. So you can go through this, and you can create your own animation. So several image files actually are being created. Then you can just play over these image files, and you will be able to see an animation, right? A GIF. You can create a GIF file so that the animation can be seen, right? Try this at home. It is very interesting. That's why I have given you. Okay. So we'll move on to our studio. I don't think I have sent you these files, these lecture notes. I'll send you those lecture. Let me check whether I have given you. I think I haven't sent you these lecture notes. Um, yeah, only up to the heat map I have sent you. I will send you this presentation, so you can uh, go through it, and at least you can set up your environment for our studio, right? So R, if we talk a little bit about R is something like C, Java, C++. It is a programming language, and it has a software environment for statistical analysis and graphics representation and reporting. So R is specially focused on statistics or analyzing things, and you can graphically represent things using R, and you can create reports. So it is very easy. It is a programming language, but it is not too technical like Java and other programming languages. It focuses more to statistics and representation of certain analysis and reporting. Right. So it is freely R is freely available under the GNU general public license, and precompiled binary versions are there. So you can use R in Linux, Windows, Mac, any operating system. So this programming language was named as R based on the first letter of the first name of two R authors. So these people have invented or have created this programming language, and yeah, it is created in Bell Labs. So most of the programming languages and software related stuff have been created and researched in Bell Labs. So, so that is a very brief introduction about R. So what you need to basically know is R is a programming language which is related to statistics and representation of the analysis. It is a well-developed, simple, and effective programming language. It includes conditioners, loops, user-defined recursive functions, and input and output facilities, which is very much required for analyzing data. Right? R has an effective data handling and storage facility. It provides a suite of operators for calculation on arrays, lists, vectors, and matrices. So in R, we focus to load data onto arrays, lists, vectors, and matrices, right? I don't know whether you have any experience with MATLAB. So if you have experience with MATLAB, it is also a mathematical software where you can analyze, do image processing, and lot of stuff. Uh, so R is, I mean, the functions in R is pretty much similar to the functions in MATLAB. The concepts are pretty much similar, right? So you can use arrays, lists, vectors, matrices, those kind of mathematical representations to represent your data. So R provides a large, coherent, and integrated collection of tools for data analysis. So there are a lot of tools where you can use for your analysis stuff. Then R provides a graphical facility, provides graphical facilities for data analysis and display either directly at the computer or printing at the paper. So you can, it provides a graphical representation uh, where you can visualize what you have analyzed. So it is the final step, if you can remember. We did in our theoretical part in business intelligence. Finally, we have to visualize what we have analyzed. Otherwise, the people, uh, most of the people won't be able to understand since they are not technically rich, right? So this is the programming language. R is the programming language. R Studio is the kind of IDE. So you know, for Java there is NetBeans, Eclipse, and for R there is R Studio. So it is an integrated development environment for R. A programming language. R is this programming language for statistical computing and graphics. Uh, RStudio is available in two formats. One is RStudio Desktop. It is a regular desktop application, and RStudio Server is there, which runs on a remote server and allows accessing RStudio using a web browser. So you can use the web and access RStudio, R server, RStudio server, right? But it is better if you can download and install R into your machine. So it is not a very large application. I mean, it does not take a lot of capacity in your machine. So you can, first of all, you have to install R, the programming language. So here is the link I have provided for the Windows base. You have to download from this link. If you are using Linux, Mac, or any, yeah, such um, operating systems, you can always go to this rproject.org and select the specific OS and download it. Right? So that is R. You have to download and install. Then you have to download and install R Studio from this link. So I have provided this link as well. You can download and install. Right? So basically, R Studio, the view of R Studio is like this. You have four, I mean, the window is divided into four parts. Give me a second. Okay, so the application itself is divided into four parts. Um, so this is the data that you have loaded, right? This is here on the left upper part. There is the data that you have loaded. Maybe the CSV file, So if you can remember, we worked with the CSV file which includes tsunami data. So that file is being loaded here. So when you load the file into your project, it will be seen here. The environment or the history, the data. So if you are creating matrices and arrays and lists and everything, they will be appeared here, right? The global environment will be shown here. The browser, where to browse, from where you have to browse the files and packages and all of those things, those information is available here. And finally, this is the console. So here is the place that you type your code or type your R commands in order to analyze the data, right? So that is how RStudio can be viewed, and that is how you can work on RStudio, right? So I will show you. So I have installed, yeah, I have installed RStudio application. Yeah. So this is, this is the setup, right? So this data I have already loaded this data here. So you can simply just go to file, new file, or maybe new project or open file. So you can open file and go to the particular place and load the file. So yeah, so this is the data file. So you can just click this and open it. So when you open it, it will be loaded to here, right? So initially I haven't created any lists or arrays or anything. So nothing will be appeared in this part. Environment is empty, right? And remember, there is also a tutorial available, so you can always go to this tutorial and uh, see or learn uh, certain commands in R, right? So and here in the console they say type demo for some demos, or help for online help, or help.start for help. So you can try these commands and have the, start, you can um, start to know the basic idea or the basic concept here used in R. Okay. So I have included some basics in your presentation. So I think it is not very hard, this part, because uh, similar to other programming languages, uh, the basics are pretty much same. So if you want to add a comment, you just type hash and write your comment. And here you can just type the variable name itself. You do not have to you do not need to specify the data type and the size of the variable like that. Those things you do not have to specify. So you just type the variable name and you can just simply assign a value, maybe a text value, maybe an integer value. Just simply assign using this arrow kind of thing. So I'll show you. So I'm going to type, so I'm typing it in my console. So my string is the variable that I am creating, and this is the greater than mark, and the hyphen will be used to create this arrow sign, and inside this variable I'm going to just include a set of words like world or something like that, right? So when I click enter, you can see here under the environment tab a new value has been created. So my variable has been created here. You can see the variable here. So the variable name is myString and the value which is inside the variable is hello world. So if you move the cursor on top of this variable, you can see it is a character type variable because I have included characters. So the data type has been automatically taken as characters. Then the size is 120 bytes. It means the size of this of the set of this set of these letters, right? So since I have included a set of characters into this variable, the size they will take the size of these characters, right? So this is the concept. I mean, we type here, we include I mean we create variables, arrays, lists and everything, and those the things that we create will be available here in the global environment, right? uh, and R does not support multi-line comments, unlike other programming languages. You cannot include multi-line. So if you want to include a multi-line comment, multi-line means a comment with many lines. If you want to include that, you have to do something like this. You can type if false. So it will not it will never go inside this if clause because false is there, right? The condition is false always. So it will not go inside here uh, since the condition is false. Okay, so um, so if I want to view a value which is inside a variable, I can simply type print. So print print. So when we are typing keywords, you can see a window or pop-up will be given here. So you can use this uh, word, this keyword print, and I'm going to print my string. So you can use control and space, right? You can use the keys control and space uh, in order to fill the maybe the way. So for example, I'm typing my and I'm using control and space and it will be completed, right? So since I only have one variable with starting with my, and then it will complete the name of the variable. So it is pretty much similar to any other IDE. So I'm going to click enter, and you can see hello world will be printed here. So the value of my string is hello world, and it is a single character array. So you can see here this one represents the number of rows in the array. So it has only one row, and it is a character array. It is mentioned here, right? So if you want to create a vector, you can create something like this. If you want to create a vector or something like an array, you can give a name and then you give this assignment sign, and C means you are creating a character vector, right? And you can give the values which inside which is there inside the vector, right? Uh, so since it is a character, you can use C in front of the vector itself. So it is something like this. So I'm creating a character vector, uh, and I am yeah. Apples can be red. Apples can be green. Apples can be yellow. So just simply some characters. So when I click enter, you can see this apple vector is being created. The type is character and the size is 248 bytes. So you can see that there's a character vector or character array is created, one row and three columns, right? So all the information is given to you. If this vector has one row and three columns, the values are red, green and yellow, right? So if I simply type print apple, you can see the values will be printed. If you want to get the type of the vector or the type, the data type or the class, you can print class, right? Print the class of the uh, vector. Print uh, class, sorry, yeah, class, and inside it you can give the name of the vector. So the class is character, right? So similarly, you can print the class of myString. So it is also a character, right? So like that uh, you can print the, you can get the data type of any uh, array, right? Array or variable. So that was about a vector. So here this is how you create a list. So in a list, uh, list is something like this. So in one row there are what do you say, certain values. So there can be vectors and variables and functions. All of them can be included in the list, right? It is a list of something. Variables, functions, arrays, all of them can be included in the list. So this is how you create a list. You first of all give the name for a list, and then after this assignment sign, you say that I'm going to create a list. So this is a keyword. Here, list is the keyword, and inside you have to go on typing your list. So in my list, I have a character array or character vector. So I'm going to type the vector, and then I have a variable, means a value. Then I have a function. So all of them I can include in my list, right? So list, I'm going to give a name my list, and I'm going to assign. So I'm going to create a list. Okay. So first of all, I'm going to include a character array. So this character array can include some numbers. So since this is a character array, I'm going to include something like this. So remember, these are characters. Okay, so I'll just write some letters so it will be easy for you to understand. Uh, this is my character array. That is the first element of my list. Then I'm going to include some data or a variable. So since I am including a numeric data, I am not going to write any what do you say, these inverted commas. Then I'm going to include a function. So here sigma, sine, sin. So there are a lot of functions. So I'm going to include the sine function. Sine, I'm not going to include any value. Just oops. So when I enter this, you can see my list is it is a list. So list of 3. There are 3 elements in this list. So I can expand the list, and this is how the list appears. So on the first row there is a character array. In the second row there is a numerical value, right? In the third row there is a function. So in a list you can include any data type, any kind of data type together, right? So that is the list. So if you want to see what is inside the list, you can always look here also, or otherwise you can just type print uh, my list. So they will show you in the first row there is a character array. In the second row there is a numerical value. In the third row there is a function which is which is the sine function. Okay, so the function name is also given here. So that is how you create a list. I told you another data type is, how to store the data is by creating a matrix. So you can create a matrix uh, like this. So matrix means there are it comes like this. There are both rows and columns, and one element or yeah, one element in a matrix has a row name and a column name, right? It belongs to a particular row or row and column. So how to create a matrix is you first give a name for a matrix, and then you have to say that you are going to create a matrix here by mentioning the word matrix, right? So inside the matrix, uh, you can include all the data, right? So since it is a set of character data, I'm just going to include all the characters like this. So you do not have to organize it into certain columns or rows. You just specify all the data, and then you mention the number of rows, the number of columns, uh, and how you start, how you have organized the data. So here the number of rows are 2, number of columns are 3, right? So when you say number of rows are 2 and number of columns are 3, they uh, the RStudio automatically distribute these 1, 2, 3 data into 3 columns. That is the first row, and in the second row 1, 2, 3, these 3 data into the relevant columns, right? So that will be organized by the RStudio itself, right? So Clear? So this is how you are supposed to write it. So you can give a name, my matrix, and this sign, and it is a matrix, and inside the matrix I'm going to give a character array. So uh, yeah. So I'm typing A. So these are the values, right? So just simply go on typing all the values that you need to include in your matrix. Right. So I have typed 6 values because I am planning to create a 2 by 3 matrix, right? So number of rows. So when you move the cursor on top of this command, you will see the explanation or the description of the command. So it will be easier for you to understand. So n rows or number of rows will be 2, and number of columns will be 3. Okay, so I'll just simply enter this, and you can see my matrix. My matrix is created. So there are 1 rows, and there are 6 values. Not 1 row. I mean there are 6 values. So you can see these are the values, right? Uh, you can print. If I print my matrix, you can see the rows and columns will be shown like this, right? So next you can create an array. So list, sorry, vectors, lists, uh, and arrays, matrices and arrays. Those are the ways that we can uh, store data, right? So when you are creating an array, you just give a name. The similar format is there. Give a name, and then you mention that it is an array, right? So here dim means the dimension, right? Dim, dimension of an object. So you can see here, when we are creating an array, first of all, I have given 2 values here, green and yellow characters, and I have given the dimensions. So dimension means the dimension will be 3 by 3 by 2. So these are the x, y, z values. So x means the number of rows will be 3, number of columns will be 3, and the number of z values will be 2. So I'll just create this array. So I'm going to type my array, and here I am mentioning I have to mention array, and inside this array I'm going to write a character vector. So like this. So I'm typing green and yellow, and I'm mentioning the dimensions. Means this dim it will be 3 by 3 by 2. So the x value will be 3, which means 3 rows will be there. The y value will be 3, which means 3 columns will be there. And z value will be 2, which means there will be 2 sets of 3 by 3 arrays. Right? So I'm going to press enter, and you can see my array will be created. Right? So 3 by 3 by 2 will have so 3 by 3 means there will be 9 elements, and if you have 2 sets of those, there will be 18 elements. So you can see here it is a character array which has 18 elements, right? So you can simply print this one and see. Print my array, and you can see, so this is one. So z has 2 values, so this is one set of 3 by 3 array, and this is the other set, right? So there are 2 sets here because uh, the z value is 2. So if you write the z value as 3 also, there will be 3 sets, right? So you can see here 18 has been replaced by 27. So if I print my array again, here there will be 3 sets, right? So green and yellow will be included like this, one after another, right? So like that you can create arrays. Okay. So the other one is this. So these were about lists, arrays, and stuff. You can use different ways of assignment in RStudio. So you can use the assignment value, the equal operator. You can use this pointer operator like leftward operator, or you can use the rightward operator, right? So if we print the variable, print these variables. So variable 1 has the assignment using equal operator. Variable 2, right, variable 1 has assignment using equal operator. Variable 2 has the assignment using the leftward operator. And variable 3 has been assigned using the rightward operator. So if we print these variables, the values of the variables, so if we print variable 1, it will simply be a character array like this, 0, 1, 2, 3. If we print if we print variable 2, right, it will be printed like this. Learn R. The leftward operator has been used here, and these characters will be printed like this. Then variable 3, if we print variable 3, true will be printed as 1, and 1 will also be printed as 1. So you can see here it is the same thing. Even we use different kinds of assignments, the same thing has happened. Even if we use the equal sign or the leftward operator or the rightward operator. So remember, when you are using the rightward operator, you have to uh, write the assignment variables, or what you are assigning uh, relevantly, in a relevant way, right? So if you use variable 3 here, and the character value, or this value here, something else will happen, right? So that is up to you to think about. I think this assignment and this kind of things you have done when you were uh, learning other programming languages and stuff, right? Okay, so those are the basics of R Studio. There are many more other basic things that you need to learn. So you can always go to the tutorials point in on the Google, and you can learn about R Studio. And there are many other tutorials online. So it is very similar to or any other analytical processing software, right? Okay, I have given you some what do you say, some libraries or some functions that you can use for analyzing, right? So since this is our first day with R Studio, I'm not going to explain all of these functions here today. Otherwise, it will be very heavy for you, right? So yeah. So I have included some functions in your uh, in the presentation. So you can first you have to do you practice with these basics, right? First of all, you have to install R, and then you have to practice with the basics, and then afterwards you can move on to uh, using these kind of functions, right? So you can just you can see this or go through this handout, and you can learn them. Uh, so I'm not going to explain these things today. So I'll explain these things in the on the other week with some activities for you. But until then, you have to you can practice, so you can uh, type these functions and see what happens, right? uh, just don't just type what is here in the slide itself and go to the next slide. No, you have to change the values, the variable, the settings of some functions. So for example, if you can type, yeah, summary, and you can see there is an explanation of summary. So summary is a generic function used to produce result summaries of results of various model fitting functions. So a summary is a function which has a specific thing to do. So you can press F1. So here I have selected summary. I mean, I have moved my cursor on top of summary. And if you need further explanation about summary, you can just press F1, right? In your keyboard, you can press F1 and a description will appear here, right? So our object summaries. So you can go through this information. There are examples as well, how to use the word summary, right? How to use this keyword, uh, right? And certain arguments have been given. So with most of the uh, functions, there are certain arguments where you can use to change or create use the function according to the data that you have, right, in an optimum way. If you want to optimize the function, you can change the change the arguments of the function, right? So like that, when you press F1, you can always have additional information about a certain function. So hist means a histogram, uh, box plot. So these are very important analytical, I mean, important functions that we can use to visualize our analysis, right? So after analyzing and after cleaning and interpreting all the data that you have with you, uh, you have to visually represent it. So you can use any of these functions like histogram, creating box plots, creating other charts. You can clearly visualize your results, right? So that is the most important part, because you might do a very heavy job while analyzing, but if you are unable to present it in a meaningful manner, then it is no use, because because people who need to know about the information won't be able to understand what you have done or what results you have obtained. So uh, representation or presentation of your result is very important, right? So you can use this kind of what do you say, this kind of functions to clearly and yeah, clearly represent your findings, right? So I have also included some other basic functions, and afterwards you can see I have also included how to load a file to RStudio using the command prompt, as well as uh, there are other easy ways to load the file. Uh, yes, you can view data in the console, and you can create a summary where certain statistical summaries will be provided with the file. So from that summary also you can explain something, right? You can get the summary and you can explain about the data which is you have loaded into the application. So there are some other functions that I have given here, where they will be important when you are working with imported data. Here also you can create heat maps. So if you can remember, heat maps are very essential to explain something, right? Uh, Especially with the distribution of data, you can explain something in a very clear manner using a heat map. So heat map here in RStudio also, creating heat map is available, and it is very important, and it is better if you can use a heat map to explain what is given in your assignment as well. So the first and second questions are related to R and R Studio, right? So yeah, you can go through this handout and you can try this. However, I'm going to explain all of these functions and how to um, work with these analysis, work with the data and analyze it on the next week. Okay, so prepare with the basics, and you will be able to understand uh, correctly or easily what we are going to do on the next week. Okay, so download R, install it, download R Studio and install it, and do these basics, right? Be familiar with the basics. Don't just type everything here and just close the application. No, you must change the arguments of these keywords, right? Of the functions, change everything bit by bit and see what happens, right? So that is how you learn things. You should change what is given here and you will see what happened. Okay, so any questions related to what we did today? So I'm going to stop by now, uh, and I'm going to let you guys do and do these things and familiarize. So I will send you this handout and the other handouts relating to PostgreSQL. So you can prepare your environment, like you can install Postgres and you can be ready. Okay, so any questions related to what we did today? No? Any questions? Okay then. So if you do not have any questions, we will stop for today and we will continue on the next week. Okay then. Thank you.
Thank you, ma'am.
Thank you, ma'am.